Well, good afternoon, everyone. Hey, how are you? My name's Chris Hadfield. This is Steve Jurvetson, and I think we have about a half hour to talk about some of the amazing stuff that Steve has done, the stuff he's up to, but maybe more importantly, where he thinks we're all headed with all of this stuff. And I've known Steve for a few years. We're working on a couple interesting moonshots together, actually.
Literally.
Literally. And I thought maybe initially it might be good just as an introduction for the folks that haven't met you. You grew up in Dallas?
Well, I didn't grow up, but yeah.
But you don't sound like a Texan.
Yeah.
But you went to Stanford. I'll brag on his behalf. Did his degree in 2.5 years, first in his class. Went on, did a master's, and then has been working for some of the big names out there until people recognize the incredible individual talent that Steve has. Started working in venture capital with a couple different groups of people, and then in the last year has formed your own venture capital or venture firm, Future Ventures.
That's right.
And what did I miss? Go ahead, introduce yourself.
Sure. No, thank you, Chris. No, I think that's all relevant, and I mainly invest in moonshots, quite literally. That's what we pitch ourselves as doing. Our logo on our business card is a little, astronaut with a flag on the moon. And this is everything from, companies like SpaceX and Tesla, where I'm on the board, as well as a Canadian company, D-Wave, building quantum computers. And generally speaking, we try to invest in companies that if they succeed, history books will be written about. And that's a pretty audacious claim on behalf of those entrepreneurs, but that's exactly what we look for.
Yeah, and you've had a pretty incredible track record of choosing some that are currently writing the history books right now. And I want to touch on several of them. Let's start with something maybe that people aren't expecting, and that's food. You've been involved in a company for quite a while now, I think, right? For
a couple of years, which feels like quite a while.
A couple of years, which is a long time in the Valley.
Yeah.
That is looking at how we produce food and what it means, not just from a profit point of view, but also from other motives as well. You want to talk a little bit about that?
Sure. I think you're thinking of Memphis Meats. I have invested in a variety of specialty protein and algal fuel companies and algal food companies prior to as sort of predecessor investments. But I had spent a good 5 years trying to find what I affectionately call synthetic meat, and that's not very appetizing to the average person, so we're coming up with better names for it. But generally speaking, how can we make meat without the animal? Imagine meat as a manufacturing process, a steak, a cutlet, a fillet of fish, whatever it might be. We're, of course, so accustomed to the notion, well, that comes from the animal you harvested from. How else would you possibly do it? But imagine with synthetic biology, with cellular engineering, with growing mammalian cells in a vat, that you could take a few stem cells from a cow, a pig, a chicken, grow them outside the animal, and produce a plethora of food products in perpetuity from that initial stock. That is now possible. The state of the affairs is that it's an R&D phase. They're scaling up early pilot plants. But
what's the limiting technology?
It comes more from the science and the biology of how do you basically efficiently grow stem cells, feed them a food stock that's not perfused with a heart and vasculature. So in other words, how do you grow skeletal muscle eventually without vasculature, without a heart, without a mind, without methane, without a GI tract, without a cow, right? Without mad cow disease, without any of the negatives of the food industry, but just grow the muscle, nothing but the muscle. And to do that, you first grow stem cells, make them pluripotent, and make them basically immortal, and then differentiate them to skeletal muscle. Every cell in, let's say the one, like my wife is pregnant currently, our baby was a single cell at one point, but eventually that subdivides and becomes muscle, bone, brain, everything, right? So how do you differentiate just to the skeletal muscle you want in a manufacturing process? And that's been shown. So another way to answer your question, the current risks are, can you get the feedstocks cheap enough, like what you feed these cells that want to grow in a vat? And then can you differentiate it into muscle in a way that's indistinguishable from the real thing? So it's got the same mouthfeel, the same texture, the same fat to protein ratio. It's the same thing, right? And then that's how we think we finally make a change in food habits.
And I think there's a lot of people here that aren't just interested in this technology, but in your ability to identify something that will have history books written about it. So what is it about this technology that makes you think this is the time in history where we're on the cliff, where this is going to be something that is going to start to become profitable? What is the mental process you went through over the last 5 years that led you to where you are today?
I love the question because it was a challenge. 5 years ago, well, actually now 7 years ago, because I searched for 5, then subsequent 2 years I found one. People were talking about things like this. We met with entrepreneurs who had the dream. But for example, the very first company that we found that was addressing this broad category of cellular meat said, well, we use something akin to a 3D printer. We will grow cells and then we'll just lay them down. And they were coming out of a medical technology company. They literally had grown a bladder. I met a kid who has a bladder that they grew and he's perfectly fine. They were growing kidneys. And those were very high priced, but very slow custom builds. Like this is a kidney for your body. And that's great. The slowness of a 3D printer doesn't hold them back as much because it's one-off production. Whereas, you want to produce metric tons of beef, good luck, right? I happen to know that just isn't going to get you there.
I know on the space station right now they are printing organs as well, and they think that the lack of gravity will allow the vasculature to actually not collapse under the force of gravity as they're printing it, which is a problem when they do it on Earth. But it's, as you say, it's not a profitable thing. It's more at a research stage. So what was it that brought you to the next step?
So we had been in parallel investing in companies that were scaling for mass production of industrial chemicals and fuels, like using algae, let's say, to make a fuel or a protein or a chemical. And we could understand from those experiences what has worked, what hasn't worked for the reproduction rate of single-cell organisms, be it an algae or mammalian cell in solution. And then just the simple insight that a three-dimensional volume of manufacturing is going to be more akin to our own body than a planar 3D printer. So even though it says 3D printing, you're printing on a 2D layer at a time. That's just inherently slow. And so the epiphany was, here's an amazing entrepreneur, Uma Valenti, who started the company, who was a cardiologist, stem cell biologist. The right group of people came together, and we just had that belief that they were right. Like the great entrepreneurs have this infectious enthusiasm where you can't not invest in their company. They're just so compelling. But it has to also logically hold as the success is one of the possible outcomes. That has to, as Elon likes to say, that has to at least be on the table, that the basic physics supports the proposition they're proposing, right?
And so that process that you follow, I've been in your house in the morning when you're scanning a bunch of ideas, but I don't have insight into your own head. And the filter with which, you mentioned a couple things right there, the same as Elon. The fundamental tech needs to be believable to you, but you also need to see in those people something that is maybe as revolutionary, at least as capable as the tech that's underpinning it. So you've done this a lot. You've been doing it professionally for many years. For the folks in the room that are either providing money to people or who are people that need money for the projects they're working on, can you just tell me, is it just intuition? Do you have a checklist? How do you do that evaluation to arrive at the failures that you've had, but also the great successes you've had?
Now, so there's a part of the answer that's somewhat inscrutable to the outside. I'll start there because it's the most valuable to me, but it also may be the most difficult to imitate. And that is, throughout my entire career, and I've been a venture capitalist now for 25 years, I've applied a simple rule from which everything else impacts, and that is, I try to invest in ideas that are unlike anything I've seen before. Seems pretty simple, yet adjacent to an area of prior expertise. So, for example, I wouldn't invest in real estate and casinos and oil and gas because I don't know anything about those, and they have nothing to do with anything I've done in the past. So I kept referring to the adjacency of the algal oils or the specialty proteins or synthetic biology in general that gave me a prepared mind. But when the particular company came, it was the first of its kind. And so as I look back over my portfolio of investments, in the vast majority of cases, there was no alternative. There wasn't any number two I would have gone to invest in if I hadn't invested in number one. Like SpaceX is a simple example. There was no credible alternative to SpaceX. It was so insane at its founding to colonize Mars as a founding mission that was one of a kind and still is. So the reason I say that's somewhat inscrutable to the outside is no one knows what I've seen. But this is potentially something any investor could adopt in their own career path over the course of decades, is to say, where are you uniquely qualified to look at something in contrast to every other investor out there? And I'd say the warmth of the herd, the enterprise software and consumer internet where everyone is investing, and I just heard backstage, 40% of all venture capital dollars end up in the pockets of Google or Facebook ad buys. That's terrifying to me. I'm like, what an insane metric for where all the money's going, right? And then, because obviously some of that money's going to employees, some of that money's going to real estate, some, WeWork and others, to think how little of that is going to synthetic meat, to colonizing Mars, to solving the climate problems, to real meaningful change outside of software that it really shows that there's not much there. So I've always tried to say, where is there an unmet need in a market as an investor? Try to gravitate towards that. And if it's going to be leading with technology, that's going to continuously change. 5 years from today, I couldn't tell you where I'll be investing. By definition, 10 years from now, I probably have a really bad guess if I tried to guess. And 10 years past, I would never imagine I'm on the boards of the companies I am today. It's unfathomable to me that these companies would be even appropriate for venture investment. And the bigger underlying theme, I think, is that every industry is becoming a software-centric, simulation-centric business. So automotive, aerospace, agriculture, construction, fintech, these are all sectors that haven't faced substantial disruption or new entrants for decades, sometimes a century, like in animal production. And when you do with a software-centric, nimble startup, the incumbents just roll over. So it's an incredibly great place to invest if you can find the great team with a breakthrough idea that sounds like it can scale. Right? It's not like a science project where you hunker down for 20 years and maybe you've solved nuclear fusion. It's something where you iterate with customers along the way, and like SpaceX is a great example. It's not like do nothing, then colonize Mars. You can see it is a great example how you get from here to there.
And Memphis Meats and the other companies have been looking to just sort of independently create meat without all of the biological substructure. But on the other end of the human body with the brain, we are now getting maybe to the point where our non-biological but artificial creations are approaching the level of intellect of animals, and maybe eventually fairly soon all the way to the intellect of us, and then beyond that as well. And so when you talk about you don't know where you're going to be in 5 years and you sure don't know where you're going to be in 10 years, I would be very intrigued to hear what your thoughts are on artificial intelligence and machine learning, benefits, negatives, what you think of the OpenAI and the work that's being done there. How do you think it should be addressed in society? Because, we have in the past invented dangerous things, and then we have found societal ways of regulating them and controlling them, right. Knives and nuclear power and all kinds of things. So where do you think that all fits in, and what do you see in your less than perfect, but maybe clearer than most 5 or 10-year-old crystal ball of where we're going to be?
It's actually a great set of questions. Each one of them could be well over a half hour. So if I don't if I forget to hit one of the subpoints there, let me know and we'll circle back. Okay, good. So first, let me say I've been a big believer in the power, in the resurgence and a renaissance in AI that's going on, and I'll try to explain why I think now's the time. And interestingly, it was out of Toronto, in the University of Toronto, that this whole renaissance started in 2012 with Hinton's lab, and then later Yasha Bengio out of Montreal and a bunch of others. So this is ground zero for the AI revolution, just for those who want to go Canada. Seriously, and there isn't like an obvious number two. It's like this is where it's at. And part of the reason is that it was a field that was dormant for many years. I actually started a PhD of all things in neural networks in 1989, and gave it up after a couple of quarters because at the time it didn't seem right, and for a variety of personal reasons, I thought that was going to be way too focused and narrow. And luckily, just pure dumb luck, I put that aside for a good 20 years because it really was too early. What happened was, in the interim, was computational substrates morphed and have changed such that the GPUs from NVIDIA became available. And around 2012, the cross product of people like Hinton and others who stayed with it, the few, like a handful of researchers who stayed with it, finally had a computational substrate that wasn't just Intel CPUs. And a simple way you can think about this is our brain is very different from an Intel CPU the way you used to think about it 20 years ago. It is a multi-processing, slow compute with a lot of interconnect, like every compute node connects to 1,000 of its nearest neighbors in a 3D volume. It's just totally different from the way we build chips in a planar process. But the GPU was a major step in the direction of a brain-like architecture. So, make a long story short, this massive renaissance starts around 2012, and around 2014, I was debating other VCs on what are the most important tech trends for the next 5 years, so that brings us to today. And I argued that machine learning / deep learning, basically using these new neural network algorithms in some form to make what we call small AIs and then eventually bigger AIs would be the most important tech trend. And it was heavily debated, but I believe it's true. I think it is the most important thing happening today.
What year was that triggered?
2014.
14.
Yeah, so we invested in Nervana, a custom silicon to do this better than GPUs that Intel acquired and now is shipping. Subsequently, Mythic, which is doing analog compute, much like the brain. It can do basically a huge multiply operation and addition in a single transistor in the analog domain, so it's closer to our brain even still. Each of these is like a 100-fold improvement, let's say. So taking Moore's law on steroids. But let me not get too deep into that, to just say the way that we map this to its silicon has gotten better. That's the main takeaway. The algorithms have got a bit better, and we have a lot of data. So because of the internet, because of tagging and crowdsourcing and just the sea of data that's available via Google and others, you can train these things. So the way to think about neural networks or machine learning is it's like a little brain. So for now, they're little brains, but they'll scale. And they can learn anything. Just like an infant that's born could be an English-speaking, French speaker, sometimes both, German, but not all languages of the earth, right? Like, good luck. No human speaks all languages of the earth, right? And you know that your brain could, but you choose to train it in a certain way. In the same way, these AIs could do anything. They're domain independent. They could be used for speech recognition, for vision systems, you name it. Usually the sensory cortex is what we start with. But they're getting more and more powerful, and they're knocking off more and more parts of what we consider to be human. So today, think of it this way. It's almost like a recapitulation of our biological evolution. It's the simple stuff, the limbic system, reflexes, pattern recognition systems, danger, security cameras, recognizing human faces, recognizing your mother's face, recognizing threats and picking up acoustic signals. Basically, the first layer into your brain, sensory cortex. That's what we're nailing today. There's no reason this methodology couldn't recapitulate the whole stack, right? On a path, iterating our way to superintelligence. And here, to give you a sense of scale, Google Brain, when they recognize cat faces on the internet, this, by the way, like a child with no training. This was what's interesting about this exercise. You don't say, that's a cat, that's a dog. You just show it a bunch of YouTube video footage, and it recognizes cats on the internet, because there's a shit ton of cats on the internet, right? Just like an infant. It's kind of like one of those spooky moments. Anyway, that's about 100 billion neurons. We as adults have about 100 trillion. As an infant, you have about a quadrillion. Actually, synapses, I'm talking about, not neurons, I meant synapses. What counts is the connections between these things, not the aggregate number of nodes. So the number of synapses you have as an infant is 10 times what we have as an adult. There's a lot of pruning. And we're off, from 100 trillion to 100 billion, you're off by 3 orders of magnitude. 1,000x, that sounds like a daunting challenge, right? That's only 10 years of Moore's Law, right? If you double power every year, and lately it's more than that because of NVIDIA and Nervana and Mythic, just wait 10 years and we'll, no special magic required, you'll get at the scale of a human brain. And that's where it's kind of mind-bending. So people in AI have typically said, oh, but for the software, of course. And if you had an old modality of like, I'm going to write some sort of rules-based system that says it's going to somehow magically be intelligence, there's no reason why that would ever work, right? I don't think there's no existence proof of people building something smarter than themselves, except for these neural networks. It happens everywhere. When you train those little brains, they're superhuman. They're better than human in everything that we set them out to do. They can translate languages better than humans. They can recognize cancer and pathology slides better than a human. They can do X-ray radiology better than a human after a few months of training. There's no reason to believe that this wouldn't, if you give it enough time, recapitulate our own path to intelligence and superintelligence and then blow right on by us.
So, yeah, it's kind of an interesting thought that it's not like you're building the intelligence, you're building the technology that allows intelligence to occur.
Exactly. You still have to train them. So it's like an infant that knows nothing. You still got to train it to become a teenager.
Okay. Yeah. And so with that trajectory that you've been looking at and investing in, where are we right now, and where are we going to be, and what do you think societally we should be doing in order to both take advantage of it, but also to temper it?
Yeah. That last part's the trickiest. I'll jump at the end. I don't think there's any way to temper it, but that'll be the provocative thing I'll circle back to. You could say we're nowhere near a mouse brain yet. We don't yet have systems that do path planning quite as well as a mouse, but we're getting there. You could look at it one of two ways. Do we have a fraction of what it means to be human, or do we have some other species of animal that we're like an ant or what have you, right? I'm not sure either are that helpful, but the one that I describe to more is sort of like working from the outside in. We got most of the sensory cortex nailed. Now we're trying to figure out the other cortical layers that functionally are similar to build on top of it. Another way to phrase it is, between 5 or 10 years, this should all become a lot more powerful than it is today, which is kind of mind-bendingly short. So this gets us to the second point, which is both good news and bad news. Good news on this whole methodology is I don't think there'll be some surprise where, boom, something smarter than a human in a course of a day. Because there are some people who think if you get smart enough that you can improve your own logic, you'll be self-improving and it'll be a runaway curve like a hard takeoff.
We'll be counting on Arnold Schwarzenegger to save the day. Yeah.
Well, exactly. And then it suddenly happens, right? And that it's called a hard takeoff. And the reason I don't think that's possible is we don't understand the artifacts of creation in this modality. You basically run these brains, as I say, you end up creating a brain that is as inscrutable as a teenage brain. You might sort of understand how you did a good job or a bad job as a parent, at that level of abstraction, but you can't dig in and like change a few neurons to fix a few things, right? It is inscrutable. So for example, I think we will build an intelligence that exceeds human intelligence before we ever reverse engineer our own brain or one of those brains. They're just as complex as ours. They're just as inscrutable as ours for their inner workings. So you can't think, I strongly believe this, you cannot control them, you cannot reprogram them, you cannot fix them, you cannot bound them to a sandbox. That's when I get to the vernacular around, oh yes, well let's make a friendly AI. How will we put a regulation in place to control it?
Let's extrapolate that two ways then.
Yeah.
On the teenager analogy. Number one, you have attempted, since that child was born, to imprint it with a set of rules that will help that independent thinking mechanism make choices that are both good for itself, but also good for the society that's nurturing it. As a parent, that's one of our fundamental responsibilities. We don't necessarily tell our child how to think or what to think, but we definitely try and give them a standard of values that by which their behaviors are going to be judged. So is there a way to do that?
I think so. I think this whole act even today, is more akin to parenting than programming, in that the locus of learning is on the process of creation, not the product of creation. So how can I be a better parent involves the process learning, learning from others glacially over decades, I'm not sure we're doing very well over hundreds of years, but we're getting better. Similarly here, every time you train a new network, you learn something better about how to train it better the next time. And so hopefully we'll cut our teeth on the early days. But at the end of the day, it's fundamentally fast, cheap, and out of control, the way Rodney Brooks once described it. In that we have to understand that no amount of hand-wringing and regulation is going to solve this problem. And so one would hope that if something was smarter than us, it would also be less violent than us, that it would be more aware of the repercussions of its choices and actions in a societal milieu, within a culture. It also follows, by the way, if you talk about a superintelligence that's non-biological, non-human, that it is a bit of a folly to think that we would control it in the same sense that would be slavery.
Right.
And instead, we might want to think about not requiring an Emancipation Proclamation for AIs, but incorporating them with some foresight into this future. Now, we're getting, to be fair, way down the path, right? Even though,
Asimov's laws,
this is a full 5 years away. To be clear, a lot of things could change. But I think it's super important that when you spend enough time thinking about the iterative algorithms that we use, that first, you don't learn about what you've made, only how you've made it. Next time around, by the way, you'd scrap one AI and build another one that's better, instead of like making one better and better and better, because there isn't again, any brain surgery that you do on these things. You just know how to make a new one, and it takes some time to train each one. So you set it up, dedicate its compute, and then spend a lot of time training it. So there's much like getting to the teenage years, it's not overnight.
Some of the most brilliant people we've had, because of their particular wiring and their chemistry, have also been some very destructive people because of the way that they think. So where do you think we are in an artificial intelligence psychosis?
Oh boy. I'm just trying to think who you had in mind on that. The psychos I know, they aren't that great. They just got lucky. But it's a tough one. So one might imagine that would exist, right? Anomalous forms. And I don't know, other than we're going to learn by co-evolving with these creatures. Here's another way to phrase it that I think makes it that this is an imperative and not something we choose or choose not to do. If I asked folks in the room, how many people think one day there will be something that is greater than human intelligence and more capable than humans in every metric? How many people think that will happen one day? Actually, this is a pretty tech-centric crowd, so we got maybe half the room. Outside these circles, there'd be a much higher percentage that doesn't think that's going to happen. And there's a trick to my question, because I didn't say a time frame. So if you imagine 1 billion years, just to pick a number, of normal biological evolution with no technology of any sort, it would be really weird if humanity was the endpoint of evolution, right? It's a bit of a hubris that we have, that we think that this is. And if you realize how we got to where we are, and that process would inevitably produce something smarter and more capable than us over the longer run, kind of like the various humanoids that you showed and hominids you showed in your opening remarks, it's the height of folly to think where the evolution stops here. And once you relax that, and don't think of it as something coming and competing with us in the current day for our resources and our carbon for some reason, but instead something that's smarter, more capable, more enlightened. By the way, the vector of enlightenment is largely cultural evolution. I think it's moving beyond the individual to how do we choose to live in societal constructs that we're slowly learning over time. It should be our greatest accomplishment to birth something that transcends our own biology and brings intelligence to the next level, that makes it easier to populate distant solar systems and propagate out intelligence out through the universe. That's likely going to be non-biological. And I think this selfish sense of supremacy that we have inherently shifts to more of one of symbolic immortality. That what, as a grandparent, what better thing than to grandparent something that's more capable than ourselves, that has opportunities we never had, that, as you said in your speech, can do things we could never imagine.
Fascinating thoughts, and it's going to be interesting to see how it evolves. We have about 8 minutes left. I want to talk about space. You somehow recognize that the combination of the technology developing and Elon's particular personality was going to be a dynamite combination that was going to allow us to do stuff as we've seen evidenced over the last 10 years. Where are we in that? What do you think of Starhopper, and where do you think we are on Earth orbit, refueling in Earth orbit, starting to settle the moon, and eventually moving further than that? Where's your thoughts on that?
It's exciting, incredibly exciting time to be alive. I mean, I think you and I both can sense the difference in the sense of just the pace of progress and the believability of timelines over the next 5 to 10 years versus, let's say, mid-70s or early 80s in the height of the shuttle era. Progress was made, but at a sclerotic pace compared to today. So hugely excited about SpaceX. Again, full disclosure, major investor and board member, so take it with a grain of salt. But I am speaking as someone who sees it on the side and this is just viscerally exciting, right? So the reason they're doing these vertical takeoff and landing tests is it is a way of double checking while things are slow and somewhat under control that all your thrust vector control and algorithms and such are working. And they did the same thing with Falcon 9 and Falcon Heavy boosters to allow them to come back to ground. So stepping back, at a high level, what all of this allows for is things generally working the first time, right? When I say working the first time, like you showed, coming close to the barge the first time they tried, and the prior effort, they were just over open ocean, and it actually came to a complete halt and was stable, but over the open ocean, so it fell over, and there wasn't a photo proof that it worked the first time. But the general secret to SpaceX's success over time has been it's largely a software company. It's the simulation stack they run internally. They develop their own CFD modeling tools and simulation stack, literally their own proprietary software to do this, to do better than industry standards. And then the iterate experimentation with hopping and landing, such that when you build this enormous craft and launch it, you have a better sense of its timetable, better predictability of how it will work, instead of in the 60s where it would take 10 to 25 failed launches before you'd finally get something like the Atlas launch vehicle to be regularly performing and then have a long string of positive launches. So this is what gives, to your question, some confidence to a timeline that this new big gleaming silver starship that looks like it should would be flying in the next couple of years, that potentially by 2023 be taking the first tourist around the moon, that by 2024 or 2026, because every 2 years you have these Mars cycles, that you bring the first cargo and crew to Mars, such that by 2050 you have a city on Mars. I mean, just to give a sense of the timeline. That is Elon's stated objective. That's what all the employees are working hard towards. At SpaceX, when you walk in the front door of headquarters, there's this enormous picture of Mars. It's been there from the beginning. And about 4 or 5 years ago, a terraformed version of Mars is right next to it. Again, everyone knows that's why they joined the company. It's not thinking small.
And that takes me to my final questions to you. And the theme of this Elevate is Moonshots. Mm-hmm. And that's obviously the Mars shot or the Moonshot that is inspiring people at SpaceX. But I want to ask you, where do you think it's taking us? What inspires you? Is it flying cars, or is it the AI world or the food world? What other technologies are exciting and inspiring you to a mental image of, in my case, of a lunar lander sitting on the moon, inspiring me to make different choices? What do you hold as your particular list of moonshots? What are you working on? What do you want to support? And where do you think that's going to take us?
Thanks. The single best answer is there are more moonshots than ever before. So I don't think we should lose sight of the fact that across almost every industry, there's something that's akin to a moonshot. So specifically, automotive, aerospace, and agriculture, just to use the A's, are great examples. So getting entirely off oil for our vehicles was unheard of even just 5 years ago. And now Germany and most European nations have a deadline beyond which there will be no more gas-burning cars. That is like a watershed moment. We can see, and it's a bit overdue, but finally, where we're going to make that transition to a fully electric, fully autonomous future. So I believe that is an inevitable endpoint. 50 years from now, all vehicles will be electric, all vehicles will be autonomous, no exceptions. And then the transition from here to there, you can debate timing. So that's exciting. Let's not lose sight of that moonshot, because that is an important impact on climate change. Another impact on climate change is agriculture. Hopefully, we will no longer slaughter animals to make meat within 50 years. Zero. Like, at least in the developed world, and hopefully percolating out to the developing world. It'll just be so much better, right? 10x less water, 10x less land, 10x less cost. No methane, no systemic risk of your supply chain going out with swine fever, avian flu, what have you. So that's an important moonshot in agriculture. Both of those are subsets of the climate change moonshot, saving the planet. There's some analysis recently that if you look at committed emissions, in other words, and this is something that other lab did recently, I just heard them give this presentation, kind of scary, but when you build a brand new coal plant in China like they're doing, you have 50 years of emissions you're almost certain they're going to have from that coal plant, because they're just not going to turn it off at invested plant and equipment. Even if they switch 100% solar and wind at a certain point, they still got some coal plants they're building today. And some would argue another 300 to come in their current forecasts. If you just take committed emissions today, we're going to get to 1.5 to 2 degrees Celsius warming, even if today we cut off and all new cars are electric, all new power plants are green. Like, that's kind of scary, that we might end up at 1.5 of the 2 that we're trying to not go past. So I think we need climate moonshot, and I don't have all the answers, but there's going to be many sub-shots there. Within AI, we spoke a bit about that. I won't get into it anymore now, to say that, to summarize maybe what we just spoke about, I think machine learning is the biggest breakthrough by far in how we do engineering since the scientific method itself. It shifts from this sort of Lego building blocks, design and control modality to more like parenting, where you are growing a solution to a complex problem, and it's the only place in engineering where you can build solutions that exceed human comprehension. And we do it routinely. It's kind of mind-blowing if you think of it that way. Okay, so I'll leave that one. Lastly, and it supports AI, is quantum computing. We didn't talk about that earlier, but again, out of Vancouver, D-Wave is the world leader, by the way, in quantum computing. They are, by every measure, they've been selling commercial systems for 10 years. They have the largest quantum computers. They're used by hundreds of customers, you name it, around the world. This is a fundamentally different way to compute. It is mind-bending. I'll just leave the teaser that the physicists who try to explain how a quantum computer is so much more powerful than anything that's ever been built before engages the resources of parallel universes. So imagine you're competing just in this universe. That's kind of limiting. There's only so much you can do in one universe. Imagine you have the refractive echoes across trillions of parallel universes and slightly different variants of your computer in those parallel universes all coming together in one solution. It is that mind-bendingly weird. We are literally this month at the point where Google is claiming the quantum computers are outperforming classical computers for the first time, what they're calling quantum supremacy. Very misleading term, but nevertheless, just take it as a little checkbox. Things are happening after decades of false or sort of premature promises of the timeline. Over the next 2 or 3 years, you are going to see increasing numbers of commercial systems, and for scientific computing, optimization problems, simulation of how molecules and proteins fold, a lot of things that have been holding back the simulation sciences from just running amok through, biology, simulation, things that are just considered computationally too hard, right? Like, how does a protein fold? Are going to become tractable. And so that's super exciting. And I love it because that moonshot's coming out of Canada.
Cool.
Yeah.
Well, that's a great and high speed. I get, every time I talk to Steve, I'm like, wow, my mind moves slowly. Just the onslaught of information. We have like 2 more minutes on the clock over there. So just to touch back to the practicality before we get out of these seats. But you carry a lot of stuff inside your head. But with Future Ventures, your firm, how do you get the research? How do you get access to those new people? Where is it, just the straight mechanics of how do you gain access to the recommendations and the people and the knowledge and the stuff that's on the forefront so that you think you're informed enough to then be able to make the right decisions? How do you organize yourself to do that?
That's an interesting question. I don't normally field that one. So what we don't do, and you might think we do, we don't hire consultants, we don't turn to outside domain experts. We feel like it's our job to understand that which we're investing in. And that sometimes means going to literally back to school. I did once for some nanotech classes, went back to college as an adult, reading random things, going to conferences that are specialized in a domain of area. But most important of all, I have found that if you announce, and I'm an active social blogger and stuff on Flickr and Facebook and Twitter, mostly Facebook though, that if you announce, as I did 5 years ago, like, I'm looking for a synthetic meat company. I literally wrote a blog post. Someone out there, have you found this? And 15 years ago, I said, has someone solved the dynamic interconnect problem from neural networks? Basically, how can we get a three-dimensional volume of massive interconnects for the brain? Because that's the next big challenge in AI. So 15 years ago, I still haven't found that answer. But if you let the world know you're passionate about, the entrepreneurs know, you're passionate about a sector, and that you convey some domain expertise in your questions that you're asking, they flock to you. So what I've found throughout my career is that if you want to invest in a new sector, invest in a company that's one of a kind, by definition, they don't really have a website, a presence. There isn't a market research report on commercial space. Back in the day, there isn't like some domain expert who knows where to find these one-of-a-kind companies. I found it better to be a magnet when you're looking for a needle in a haystack. Don't just rifle through haystacks. Just let them find you. Just go next to the right haystack, pick a good haystack, pick a good industry, pick a good sector, and try to be a magnet, right? That's why I come to conferences like this, right? And that I find is so much easier, right? They want to work with you, and they can find you more easily than you can find them. So, and it's a strange way it's inverting the whole history of the venture industry, which was very, closed doors, secretive. Like when I first joined, no one announced even what their portfolio was. It was a secret. Like you would know us if you want to talk with us. It's like, and there's still some websites for venture capital firms that have absolutely no information on them. They're just like, oh yeah, good luck.
And you're giving a talk or two here at
That's
Elevate, right? And
also, another one coming up. Yeah, my wife Genevieve.
Why don't you just talk very briefly so people can know which talks to go to about the upcoming talks for the two of you.
Sure. Unfortunately, the next one I'm giving is a crossover at Mars, like immediately after this. So we're going to jump right into Uber and head over. If you guys want to come follow us, feel free. We'll talk more about investment areas. And then she's speaking on Thursday about using AI in particular to remove human bias in recruiting. So obviously, we all carry implicit biases, whether we want to or not. It's kind of scary when you look at the data. And you can't overcome that now with a sort of recruiting tool that helps find candidates that you should interview without a human in the loop, but allowing a human to do the interviewing, of course, and final hiring.
That talk is Thursday? Is
Thursday.
that right?
What time?
Thursday.
11 o'clock.
Thursday at 11.
Yeah.
Okay.
Great.
Well, thank you both for coming, and thank you for the insights. Thanks very much.
Thank you.